Hi guys, we're going to be talking about primes today. Please take your time to like, share, and subscribe, importantly. And I hope you guys enjoyed this video. Primes are a hot topic of mathematics. But today what we're going to be doing is looking at a few conjectures about prime numbers. The first one is the twin prime conjecture, very famous. This conjecture states that there are infinitely many primes of the form A and A plus 2, where A is prime. This pair, basically. So we have 3, 5 is 1, 5, 7 is 1, 11, 13 is 1. But are they infinitely? We don't know. It hasn't been proven yet. But we have made big steps. The gap has now decreased to 246. So, meaning like that. And below. So we're still working our way towards it. Every sign shows it's true, but it might not be, okay? No one's really working on a counterproof because we want it to be true. It makes sense to be true. The next conjecture we'll be looking at is the Goldbach conjecture, right? It states that, this was not proven, so not proven, not proven. States that every even integer greater than 2 is expressible as the sum of two prime numbers. So that's also very interesting. Like, say the number 36 can be expressed as the sum of which two primes? Well, 5 and 31. There we go. Has not been proven yet. Now, one more we'll cover before we do a fun prime thingy is the infinite prime. Well, it's not really I'm not sure if it's conjecture, but there are infinite primes. And what is the proof to this? Well, it's a very interesting proof because it actually takes into account odd numbers. This was proven by Euclid and uses proof by contradiction. So let's do it now, right? Assume we have a list of primes and this is complete. There are no more primes existing. Right? Now then we form a new number. Let's call it capital P, as the product of all these smaller primes, like so. And then, instead of just doing that, because that will not be prime at all, we plus 1 at the end of it. Now this number P, it must be either a new prime larger than all of these on the list, any of those, or it must be divisible by a prime not on the list. Hopefully you understand why, and therefore it contradicts this, and then this is gone completely. Therefore there are infinite primes. Boom. Very cool. Now let's do something cool with prime numbers. So one other thing you might know is when you multiply two prime numbers together, it's of course a composite, but any random integer can be expressed as the sum of two. Oh, not sum, product of two primes. Let's not use this number. Let's choose another number, 34021. Now this number is equal to 13 times 2617. This is prime and this is prime. This is prime factorization. Now some of you might know this. Now I'm going to show you a cool trick about prime numbers. So let us move down here. This trick, you can pick any number greater than, any prime number greater than 3. So let's choose a random one, 13. Let's call it A for now. If you take A, right, and you square it and subtract it by 1, this will equal a multiple of 24. Let's start with 13. 13 squared is equal to 169. 168 over 24 gets us the equivalent of 7. Now, why is this the case? Well, let's try and figure out. So what we can do here is simply make it like that. Right. What can we do? Well, what we see here is that either a minus 1 or a plus 1 is divisible by 3. Why? Imagine these three consecutive integers. One has to be divisible by 3. But since a is prime, it cannot be. So it has to be this one or that one. So one of these is divisible by 3. One of these, 1 out of 2, 3k, let's just say divisible by 3. Now that is done, so we just need to figure out 8, right? Divisible by 8. So why is it divisible by 8? Well, let's assume you have these again. Well, we clearly see, not P, why did I write P? Okay, A is clearly odd number, right? So these are both even. Therefore, one of them is divisible by 2 and one of them is divisible by 4. Right? Because if you think about it, if you have these numbers, this one's divisible by 2, let's say. No, actually, let's use this example. 1, 2, 3, 4, 5. This one's divisible by 2. Then the next one will be divisible by 2 and 2, so 4. Then it will be 2. Then it will be 4, and so on, right? So one of these has to be divisible by 4, and the other one only 2. So therefore, 2 times 4 equals 8. So we know that this total is divisible by 8. K divisible by 8k. Well, yeah, divisible by 8. Well, I should just write 8k, right? There we go. So, boom! And there we go. We get it divisible by 24. We can try something else. From before, we had this from 2617 is indeed prime. So let's try that. 261 squared minus 1. So what do we get? When you square it, you get this number. Subtract 1. You get this number. Wow, I could have just written it once, but okay. Now when we divide by 24, what do we get? We get an integer. I wonder if is it always? Never mind. And just please subscribe and hit the like button and share button. Anyway, again, just hit that subscribe button. See you guys in the next one.